All right, well, welcome back again to the last talk of the day and the last talk of the conference. It's crazy how fast everything has gone by here. We had so much fun yesterday, so much fun today, but we are more than happy to welcome Will here to our conference. Welcome.
Thanks for having me. Yeah, it's great to be here.
And you're calling in from New Zealand, right?
I am, yes, all the way from all the way from New Zealand, all the way from Auckland.
Yeah.
Yeah,
And it was 2:30 a.m. in the morning for Praveen just now, and for you it's like you said 10 a.m. in the morning, right?
yes, which is a bit more sociable than 2:30. I think so. It's early here, but it's not too early, which is good.
That's good. And you're a Microsoft MVP as well, but in the data platform, right?
Yeah, so I that was awarded to me the start of April, so I'm fairly recent data platform MVP. Yeah.
That's awesome, yeah. And we are really excited to hear about your talk today. I think you're going to speak about serverless applications and Cosmos DB and then ML.NET in the middle of all this, I guess.
Yeah, that's definitely the plan. And I also have a live demo as well. So hopefully, um, hopefully I'm looked upon with favor and that all goes well. So that's certainly my intention. Yeah.
That's awesome. I will always like end-to-end applications, and it's always great to see kind of, at least personally, I really like to see ML.NET be used as well and deployed. And I saw that John is crossing his fingers for you, wishing you luck. But yeah, so as always here, all attendees on the stream here, post your questions in the chat, and we will definitely make sure to ask Will those after this presentation. But I don't want to hold you back. I'm really excited to hear this talk. So the floor is yours, Will. Take it away.
Fantastic. Let me just get my sweet. Okay. So good morning, good evening, wherever you are in the world watching this session right now. Thank you and welcome. Thank you for joining me. I hope that wherever you are in the world right now, that you're staying safe and healthy during these very challenging times. So welcome to this session on building serverless machine learning APIs with Azure Functions, ML.NET, and Azure Cosmos DB. Now, in this session, I'm going to show you how you can train machine learning models using ML.NET and then use those models within Azure Functions. This session was inspired by a blog post that I did a few months ago where I was just sitting in my room wondering what I was going to write about and thought, well, why don't we try a little bit of fun, try and build something cool and see if we can get this going end to end. And hopefully by the end of this session, I would have inspired you to try and build something cool using ML.NET as well. It's fairly straightforward. And even though this session, I'm going to be using a scenario of building an API, hopefully the methodology that I show you in this demonstration will show you how to inject ML.NET models inside Azure Functions that can be applied to a variety of different scenarios. So just a little bit about me before we start. My name is Will Velida. I'm a software engineer working for ASB Bank based in England. If you're thinking that maybe you've watched The Hobbit or maybe you've watched the All Blacks play a couple of games for rugby and you think, hang on a second, I don't remember Kiwi sounding like that, you're right. I'm originally from the UK, but I've been living in Auckland now for around about 10 years, so I think I'm fairly acclimatized. I'm a Microsoft Data Platform MVP. My main focus is Azure Cosmos DB, but I also work a lot with .NET in my day-to-day job, a lot with Azure Functions, like to play around with ML.NET when I get the chance, a little bit of Databricks as well. And I've been very fortunate to speak at a variety of different conferences and user groups around the world about Cosmos DB functions, and I also blog a little bit on DevTO. So let's talk about what I'm going to cover in this session today. I'm going to show you how we can use machine learning models that we train using ML.NET inside Azure Functions. I'm going to be building a very basic, but I think kind of cool API that allows us to predict taxi trip prices based on some features. So essentially, the ML.NET team have come up with this really cool regression tutorial on predicting prices for taxi trips. I'm essentially going to be taking that tutorial and then embedding it inside of an Azure function and using it in an end-to-end scenario. I'll provide a demo of it and I'll explain all the moving parts. And then we'll talk about how you can inject your machine learning models that you train using ML.NET inside Azure Functions. Cool. So, like I said, we're going to be building taking the taxi trip tutorial from ML.net and using it within Azure Functions. And for this, we're going to need two functions. So we'll have our first function, which will train our model. Now, for this scenario, I'm going to be using a hypothetical batch training scenario, which will use as timer trigger and to train the model based on data that we'll store in just a local directory. And we'll train a model and save that to blob storage. Then we'll have another Azure function, which will be our API, that will inject the model that we've uploaded to blob storage and then use that model to make predictions and then insert those predictions into an Azure Cosmos DB container. So here's just a high-level overview of our work process. Essentially, we'll have our timer trigger that will train our regression model when it's invoked. This model will then be this model will be trained based on some local data. We'll upload that model to Azure Blob Storage as a zip file. This will store our model as a URL, which we can then use to inject into our API, which will just essentially be an HTTP trigger that will insert our predictions into a Cosmos DB container. Before I dive into the code, let's just recap a little bit of the process of ML.NET and just to give you a little bit of context about how we're going to use it inside our Azure functions. Just as a little bit of a recap, these are the type of predictions that we can make using ML.NET. So in our example, we'll be using a regression formula. But say, for example, you wanted to build a classification system that analyzed the sentiment of text. So say, for example, we could have an Azure function that's invoked by events that are triggered from Azure Event Hubs, and essentially that would process messages from tweets that mention our company name. We could build a classification model built using .ml.net that analyzes the incoming messages for their sentiment and then publishes that event somewhere else. So ML.net is quite flexible in the type of predictions that we make, and combined with the functionality of Azure Functions, there's a few scenarios that we could use Azure Functions and ML.net for. And then just to recap the code workflow of actually training our ML.NET model. So we start here by collecting and training our data and storing it into an iDataView object. We would then create our pipeline, specify which operations to extract our features and apply our machine learning algorithm that we want to use using this append model. We then train our model by fitting it onto our pipeline and then evaluate the performance and iterate on it just to see if it's actually an effective machine learning model for us to use. We then save our model using the save function into a binary format, which we can then load into our applications using the load method. And then we can make predictions on that by using the create engine predict functions. However, with this create prediction engine, this is not entirely suitable for our needs. Because even though we can use it to make single predictions, it's actually not thread safe. So every time we would want to create a prediction, we would have to create an instance of that prediction engine each and every time we'd want to use it. And depending on the demand and the kind of traffic that we experience on our applications, that's not a very efficient way of of handling it. So what we can use instead is a prediction engine pool. And this is a service that creates an object pool of prediction engine objects that we can use throughout our application. Now, the great thing about this as well is even though in this scenario we're using a batch processing example, machine learning models are not static. We always want to optimize them as new data comes into our application, and ideally, we want to redeploy this without bringing down our application. And the great thing about the prediction engine pool, this actually allows us to reload our machine learning models without any downtime. And we can do this via two mechanisms. So the first mechanism we can use is using a from file method. So if we're storing our model on a local file path, we can use the from file method, which will start a file system watcher that listens to file changes and then raises events, which will prompt our prediction engine pool to automatically reload our model. So say if we have some new data coming in and we save a new model to to the local file path that we specify. The file system watch will say, hey, there's a new model here, and it will tell the prediction engine pool to automatically reload that model. Now, for our example, what we're going to be using is the from URI method. So essentially what this does, it will poll a remote location for changes in our model based on a time span that we specify. So we're storing our model in Azure Blob Storage, and we'll be making it available as a URI, and we'll poll that URI for changes based on a time span that we will configure. And you can configure this depending on the requirements of your application. Sweet. So I've talked for quite a bit. Let's actually open up our demo and see if I can do this gracefully. So what I'll do. Cool. Can you all see my screen? By Visual Studio? Silence means yes. Okay, so what I've got here, I've got my two functions. So I've got my, let me just expand that a bit. I've got my model trainer here, and I've also got my API project here. So let's go through our model trainer first. So essentially, I'm going to be training my machine learning model based on local data. So this is just a nice, simple example. So I've got a data folder here with both my test data CSV data set and also my training CSV data set. I've also got just some just a helper class here to just abstract some of the methods that I need to upload my model into Azure storage. So let's go through the model. So with the data, I've created a class here that just essentially tells ML.NET which columns in my data set belong to which properties in this class. So again, this is index-based counting, so it starts from 0. So I've got my vendor ID, rate code, passenger count, the time of taxi, the time of the trip as a float, the distance, the payment type, and how much I actually paid for that trip. And then I've got my fare amount. So this score will be the labels that I want to predict. So I've just got a separate class for that as well. Now, just to give you all a little bit of perspective of which packages I'm using. So for this project, so I've just got the Microsoft.ml NuGet package along with the FastTree package as well, since I want to use the FastTree regression model to train my data. And also I've got some support for Azure Blob Storage as well, along with the functions NuGet package that it comes with. Cool. So essentially what I'm going to be doing here is authenticating to my Azure Storage account, reading my local data file, and then setting a model path, and then adding that data to an iData view, and then training the model in this train and save method. So I'll be loading it from the text file that I passed through, the training data, the file path of my training data, applying a pipeline to it, fitting the model, and then testing our model for its effectiveness. And then if it passes a certain value, saving that model to blob storage. So let's kick this off. Let's see if this will work. Please don't download the storage emulator. Yep, there it is. Okay. Well, that was fairly quick. Just let that warm up for a little bit. While that's kicking off. Cool. All right. Awesome. So here we go. I'm just going to authenticate to my blob storage account, use my current directory to get my training data, and then save that as my training data path, setting it as my setting my test data path as to my testing data set, which we'll use in our evaluate model. Setting the model path, I've kept this as a configuration setting. You can set a hard code value if you want, but I've just done this just to practice, because just in case once we deploy our functions and if there's a malicious user that gets access to it or an attacker that gets access to it, we don't really want them to know where our machine learning models are being stored, just in case they want to mess it up and try and do something malicious with it, which will cause negative results. And now we're just going to go into this train and save model. So essentially, I'm loading my training data set from this text file using the ML context. Now, just to recap, ML context allows us to perform all kinds of operations. So in this instance, we're just loading our training data set. So now we're going to train our pipeline. So I'm copying columns using the fair amounts and then using that label for my predictions. I'm applying some one-hot encoding to my vendor ID, rate code, and payment type. Then I'm just concatenating the features to perform my predictions. And then we're just applying that pipeline that we've defined onto the data view here. So we're taking this iData view that we've loaded our file, our training file into, and then fitting the pipeline onto there. Hopefully that won't take too long. That's the problem with live demos. It always works really nice and fast when you're practicing, and then you're always aware, okay, cool, awesome. All right, so now that we've trained our model, so we can evaluate its effectiveness. So let's step into this evaluate method that I've created. So essentially, I've created an evaluate method that will pass in through our ML context the model that we wish to evaluate, and then also the test file path to apply our test data onto the model that we've created. So again, we've loaded that into an iData view which we can apply our ML context operations on. We'll transform it, and then we can get some metrics by using this evaluate function that's applied to the regression class of the ML context. So we're putting in our predictions data frame into here, and then using label and score to evaluate its effectiveness. Now, let's continue. Cool. So in this example, I'm just using the R-squared value, just returning the R-squared value to evaluate the effectiveness of this model. But if we look inside the metrics object that we've got here, we can actually use a variety of different metrics to evaluate the effectiveness, such as the root mean squared error, the mean squared error, mean absolute error, loss functions. So if you really want to test the effectiveness of your machine learning models that you create in ML.NET, you've got a variety of different metrics to evaluate the effectiveness of your model. But for this example, we're just going to keep it nice and simple, just use the R-squared value and return that back. And then I've just got a simple, very basic check. Obviously, for more sophisticated production applications, you'd want to really leverage the different types of metrics available to you to assess the effectiveness of your model. But here, if it's over 0.7, which it is, it's about 88% good fit, we can go into this model and then save this model using the ML context, and then upload it to Azure Blob Storage. Now, in preparation for this demo, I kind of prepared it earlier. If anyone's from the UK and watched that show Blue Pizza, they always, whenever they were doing demonstrations, they would say, here's one I've made earlier, just to save time. But that looks like it has passed. And cool. So So our model has been uploaded to ML to our blob storage container, and we've saved it as model.zip. So I'm going to stop my timer function and head into the Azure portal. So I've got this very simple blob storage container with ML.NET models, and then hopefully there's our trained ML.NET model. So that's a very basic, very simple example of how we can use timer functions to train ML.NET models and then just upload them to a remote location. And with this, we should be able to get, there's our URI to our model. So we'll be using that to actually inject into our next Azure function, which is our serverless API. So let me just close down all of this in our model trainer and open up our API. Cool. So I've got my models, what we've had in our model trainer as well. You can have a common class for that if you wanted to be if you wanted just to separate those concerns out. For Cosmos DB, I've defined it a insert object. So essentially it's our entire class. So you'll probably recognize these properties from our taxi trip class. This is in our taxi trip fare prediction class as well. And I've also got an ID property here as well, because when you're inserting items into Cosmos DB, you need to specify an ID for that document. And we're going to be using the third SDK option. It's third version of the SDK in order to interact with Cosmos DB, and that's a requirement just to insert items in there. So I'm going to open up my startup class. I'm going to show you how to actually add your engine prediction pool. So here we're using the from URI method, like I said, to poll our remote location in Azure Blob Storage. So there's my URI. I've given my model a name, which is taxi trip model. And every time we use that in our different functions, we'll need to specify that's the model name that we wish to use. And this is the time period that will, this is the amount of time that it will poll this remote location here for changes in our model. Just for this example, I've kept it really, really basic, and I'm going to poll that every minute. This might be a little aggressive for an API, as particularly in a batch processing example. If you're doing some real-time stuff, you might need to be even more aggressive. The point that I'm trying to make is this is really configurable, and we can use this to, we can actually change this up depending on our requirements. Now, if I open up my predict taxi fare function, essentially what I'm doing here is I'm using constructor injection to inject my prediction engine pool and make it available to this function. So this will be a simple post request that I'll make to this endpoint, predict taxi fare, and I'll pass in through the body of our request as a string, and then deserialize my object using taxi trip from our request body. So essentially what I'll be passing through is this taxi trip model, and then using that to create our taxi trip insert object. When we make a prediction, we'll be using our prediction engine pool to create this taxi trip fare prediction. What I'm doing is I'm passing through the model name that we defined here in our startup class. And then for an example, so actually the taxi trip object that we actually want to make the prediction on. So I'm using this input, which is of a trip type, and passing that through to make our prediction. Once we've made our prediction, I'm going to insert that into our Cosmos DB database using this taxi trip insert object. So this predicted fare amount will be the predicted value of our fare of our taxi trip. And then just coming through here, we'll create a new item with our inserted prediction into our Cosmos DB account. So let me add some breakpoints here, just so we can step through this a line at a time and not go too quickly. Cool. All right. So what I'm going to do is set my API up as my startup project. And we'll start that. What I'm going to be doing once this is started up and once I've got my endpoint available, I have got Postman, which I'm just going to pass post a JSON payload through to this endpoint here. So here we are in Postman. So there's the endpoint to my predict taxi fare API. I'm creating a post method here. I'm passing through a vendor ID, the rate code, how many passengers we're taking on this trip, how long the trip took, how long in distance it was, how they paid for it, and how much they actually paid for it. So I'll send that request. And come back here. So I'm going to read through that payload into a string, and then I'm going to deserialize our request body into this taxi trip object. So if we have a look at our input, we can see that it's been deserialized correctly. And now we're going to make a prediction on our input using our taxi trip model that we've trained earlier. Give it a little bit of time to think. Awesome. So now that we've made our prediction, we've got our taxi trip insert object with all the properties that we use to predict our model and also our predicted fare amount as well. So continue there, and we'll just have, now we've got this taxi trip inserted object that we're going to insert into our Azure Cosmos DB container. And then hopefully that doesn't take too long. Looks like it all passed. Did we get 200? Yes, we did. Fantastic. Don't worry about the time. We just stepped through the code just to show you. So if we go back into my Azure portal, what I'll do is I've already set this up beforehand. Go into my data explorer, and hopefully we should see our new prediction that we've made. Awesome. So I tested it earlier. There we are. So there's a really simple and basic example of how we can actually use ML.NET models within Azure Functions, make predictions on JSON payloads that we send to it, and then persist that predictions into Azure Cosmos DB. So something really basic and really something straightforward that we can use ML.NET models for. Now, if I go back to my presentation. Cool. Just before we kind of wrap this up, and this is a really, really basic example. So all we did was inject a model that we trained using ML.NET as a URL into an HTTP trigger. But the power behind dependency injection within Azure Functions, we can use this workflow in a variety of different serverless scenarios. And a little bit of experience with Azure Functions might think, well, this is a very basic example. You're using the consumption model. You're using the consumption model here. That there's other considerations that you need to think about. So do we want to really have our API suffering from cold starts and all that kind of stuff? That's true. And that is a whole other conversation within itself. But hopefully this talk has inspired you to try and build some really, really cool applications using ML.NET and Azure Functions. And the flexibility and the power behind Azure Functions as a framework, you can build all types of interesting and cool scenarios using ML.NET. If you want to learn more, I'd highly recommend checking out the ML.NET documentation that the team have provided. And also they've got some really, really cool GitHub samples if you're more hands-on, you want to scan through some code and have a play around with this. In terms of this presentation, I do have the code on my GitHub. which I'll post on my Twitter, or I'll post it on the Slack channel as well, along with the slides for this presentation as well. So that was a quick 30 minutes. I might have rushed through a little bit of it, but thank you for listening. That's all I have for you today. I hope you've got lots of questions. If you don't want to ask questions now, if you have questions later, I've added my Twitter handle to this slide. I've also added my LinkedIn as well. I'm fairly responsive on those platforms. So if you do have any questions for me, feel free to reach out.
Awesome. Well, thank you very much. That was a very inspiring talk. It was really nice hearing kind of the use cases and how we can use MLnet in a serverless way here. You got some great feedback here on the chat, and I guess one question we're going to start with directly is, you said that you're going to post the GitHub links on Twitter, right?
Yeah, on Twitter, and also there's a general Slack channel as well for this, right?
Yes,
for
exactly.
the whole conference.
Yep.
Awesome. Yeah. This is, again, like I said, this is in a blog post I did months ago. So it was one of those lucky instances where I've actually created the application well ahead of time. So I'll share that link and make it available for people to have a play around and maybe improve. That'd be cool to see if someone could actually. This is a very simple batch processing scenario. One of the powerful things about ML.NET is, say if instead of Cosmos DB you were saving it to a SQL database, instead of loading it from your data from text files, you could actually load it from a SQL database. Or if you keep Cosmos DB in the equation, you can actually load it your data as an IEnumerable, and then actually load that back up to use your as more users use your applications and more data is being added, you can use essentially the same data source to train and improve your models as well.
That's great. Another question we have here is, if you set up feedback, how do you use Azure Functions app to retrain the model?
If you set up feedback?
Yeah, I think the question is about how do you use like Azure Functions to continuously retrain your model if you get more and more data? I guess that's the question.
Well, in this example, I'm using a timer function, and timer functions essentially, let me actually, do you mind if I reshare?
Oh yeah,
I'm still sharing. So
you're still sharing?
Awesome, cool. No, sorry, I was looking at the Skype. So let me just stop that. Essentially, timer functions can get kicked off by they're essentially cron jobs. So what you do is you specify a time. I'm just trying to remember, because it's not a cron job, it's ncrob job. So there's like a specific saying in Azure Functions. So this is just a basic example. I'm actually kicking this off every 5 seconds. But you can actually specify this as a time. So say if you want to train your data at 12 o'clock or at midnight every night, you can specify that within your timer function, and every night it would kick it off. That'd be good for a batch training scenario. For real-time stuff, that would be a little bit more challenging, I think. And I confess I don't have that's not something I've had too much experience with, but yeah, in this example, we're just using a timer function to specify a time to start training our model.
Cool. Another question we have on the chat here is, any clue to the cost of training the model in Azure Functions? Have you done any real business cases with the setup?
No. So this was just like a cool sample that I've just created one day, just randomly. In terms of financial costs, not particularly, but in terms of performance, this is not something I would push to production. Not this example verbatim. There's obviously there's a whole topic around hosting options for Azure Functions, and it also is very dependent on your environment as well and the context of your business environment as well. So while today this was just a very simplistic scenario, to push, there are more more factors to consider when the production.
That's great. Well, thank you for the answer. And I think that is all the questions in the chat, I think, at least so far. Well, Will, thank you very much for calling in from all the way from New Zealand to this conference and sharing your expertise in this area. It was very inspiring to hear, and I think the audience definitely appreciated that.
Well, thank you so much, not just for letting me speak at this session, but for running this whole thing. It's incredibly challenging, the current world situation right now, and I'm not sure how it's all going to end up, but it's nice to know that through the power of virtual conferences, we can still connect with each other, we can still share ideas and present to people all around the world. And I just really, on behalf of everybody, just thank you so much for taking the time out to organize this, because even though I've never organized conferences myself, they're expensive and time-consuming beasts. So I'm really grateful to you for running this event. It's been fantastic.
I appreciate those kind words, Will. We have had a blast doing it. Thank you very much. And we're actually going to loop in Bree and Louise and John here as well and wrap this conference up. But thank you, Will, so much for doing this.
Well, again, thanks for having me. All the best.
Bye-bye.
Bye.
All right, we'll see if we have Bree and Louise here on the line, I think. Yes, here we go. All right, well, welcome back, Bree and Louise, as well, from yesterday. You've been in the background, but I wanted to make sure we bring you back at the last scene here.
Yeah, thanks for having us.
How was today?
It's been amazing, I think. It's been great. I mean, so many good talks. We've been streaming for almost 10 hours now. I am tired, but I am so inspired and full with just happiness about the great community we have across the world, right?
Yeah, definitely. I've been watching all day as well, and everyone did so great, and lots of really good questions from the crowd. It's really exciting to see what people are doing with this, and are really excited to use it. So.
I want to bring in Louise here. Louise, you have to show off your shirt here because you got it last night, right?
Finally got it.
Finally.
Part of the crew.
Awesome. This is the uniform now.
Yep.
Good. Well, one thing to kind of mention as well is that the Slack is going to stay open. We are not closing down the Slack workspace. So stay in the Slack, connect with each other, think of good open source tools and startups, whatever you want to do, or just ask questions. We're all here to communicate and connect, and I definitely want to have that and see this community grow. Both me and John are hoping that we will be able to do this again soon. I know at least that we are planning on doing some kind of ML.NET hackathon, right, John?
Yep. Early stages of planning that right now. I think we're going to try to get something announced fairly soon, or at least try to.
Yeah,
it's out there already. It's in the universe, so it's manifested itself.
Happen now.
Exactly. We said it has to happen. We're gonna do it, but I think we all need a little rest first, and then definitely do that. But one thing I want to point out as well, if you want to hear more about ML.NET, definitely follow these amazing speakers from all across the world to do so. Also, definitely follow John. He's on YouTube. He's produced tons of good videos on his topic, and he's definitely a really good source of information. Luis has fantastic blogs. I know that myself, and I follow along on those. He can definitely share those information, and he also streams on Twitch. I think LQ Dev, right, Luis?
Yeah, LQ Dev 1 for Twitch streams.
Yeah, definitely. And myself, I stream every Tuesday and Saturday on Alex Slotte on Twitch. So if you want to tune in and work on some open source tools with me and learn ML.NET, definitely do so. And Bree, I know you're always available for feedback as well, right?
I am. Please reach out to me anytime. You also can leave any feedback on the GitHub or just directly to me. I would love to hear it all. Or if you just want to tell me what you've been working on with ML.NET, that would also be awesome. So.
Yes.
And awesome. We want to thank Malibu also for her encouragement and support and all the things she's done.
Yeah, she napped a little bit today through it all, but she was mostly there for us. So she's excited too.
That is just awesome. Well, that's super nice, guys. Well, we will make sure to put all the recordings up from today on our YouTube channel. We'll make sure to put up the workshop there as well in the next few days and send you an email with all the links to remind you they're there. But please spread the word about ML.NET and the conference so we can have an even bigger crowd next time and more awesome and fantastic talks. We're looking forward to it. Any parting words, Bree and Louise, John?
Just thank you all so much. I mean, thank you to Alexander, John, and Louise. This was incredible that we were able to, a 4-person team, put this all together. Thank you, everyone that was watching. And I'm, again, just really excited to see what's coming.
Awesome. Well, thank you for this event, everyone. We have been happy to have you. And we're looking forward to seeing you next time. Have a great time, guys. Thank you.
Yeah, thanks, guys.
Thanks. Bye, guys.
And we're offline. Woohoo!
Yay!
Yes.